Hey guys, I'm Selena and here's
Selena,
Michael.
Selena, I was just at the bar and I was telling them we're going to do a talk about testing, and they said, "Oh, what a dry topic." So I thought we'll just cheers to that, hey?
Cheers, I've already got one. So
Okay, excellent.
Double parked, I guess.
More importantly, I've got this great idea, fantastic idea. Do you know how big it is?
How big?
It's going to be so big, it's going to break the internet.
What?
Yes!
It's gonna break the internet?
The whole internet's just going to get broken.
No way, I've got to get a selfie right now before that happens. Technology. I can't even find my photo. I need to get a selfie though, because, you know, if the internet breaks, I'm going to be...
You're going to turn it around.
Push the button. Push the button.
Oh, do I have to push it? Right.
Woo!
Anyway, so this idea I've got, it's going to be a bit like that. It's going to be images, and there's going to be a box where you can put in your input, and you're going to mash it away, and there's going to be multiple rounds. It's a game.
Really? A game?
Yeah.
I love games. Do you guys like games? Wow! They like games. Tell us the game.
And so you're going to see these images, and you're going to have to guess the term that was used to come up with those images, each term, and there'll be multiple rounds, and you'll get points, and at the end, you're going to get like a total of points, and there'll be a big button, and you're going to go tweet it on the internet and tell everyone.
Really? I can tweet it. I can tell all my friends my high score. They can come and try and beat it.
Yeah. So on the weekend, I thought, you know, Rails, I can do this. Rails new. Got a couple of controllers going, some database stuff, and brought in some jQuery.
Wait. What? You've got controllers?
Yeah, you know, scaffold.
You've got a database already.
Yeah, it's easy.
No, mate. No. The first line of code in every application is a test.
Oh, a test. I thought you could write those later. No? Well, how do I get started?
Well, let's put that on hold for a second. How about you describe the app to me? What's it called? What's the base state of the application?
So today's like Halloween. So let's theme it that way. And it's search term. So we'll have like spooky terms. Like the base state will be spooky terms. We'll have spooky terms in the database.
Spooky terms, right. So given the application search term is set up with some spooky terms, then what? Who uses it?
Oh, everyone on the internet.
Well, yeah, but what kind of person is going to play this game?
Oh, okay, right. So like in the theme of Halloween, maybe a ghost. Casper comes in and finds the server and starts playing.
Casper, all right. So when Casper visits search term, then what?
Well,
Blank screen?
No. They're going to get greeted with a logo, maybe a welcome message.
All right. So then he gets shown a welcome message, kind of like this.
Whoa! You've done more than I did on the weekend already. Wow, yeah, this is good. This is exactly like that.
Great. And how does the game start?
Oh, like, you know, games just start, don't they? Oh, maybe a button. There'll be big buttons. Start the game. Yeah. Oh,
right.
Yeah.
So when Casper clicks that button, then what? The game starts?
Yeah, you're in the game.
Yeah, just like that. But how do you know the game has started?
Ding, ding, round one, baby. Yeah, let's go.
Maybe we see some indication that it's round one?
Yeah, and there'll be like images.
Oh, images, right. And you mentioned something about making a guess. So how does that happen?
Right, so you get these images of, I don't know, capybara or something, and then you need to, you put your guess in like an input, right?
An input, so maybe a text area.
Oh,
you know
right.
What? Maybe we should put the pressure on too, and we give those users a time limit.
Oh yeah, you got to just guess like the 9 things, and what is it? Like 10 seconds or something like that?
10 seconds, so a countdown timer. Yeah, cool, you're starting to get it.
Yeah.
All right. So now, when the game's in progress, well, then what happens? Do you want to have a go?
Oh, yeah. So when the game is in progress, the timer starts counting down. So we've got a timer. It's gone from 10 to 9. Maybe like there'll be a status that says in progress. So the user kind of goes, yeah, this is the time. Start mashing that keyboard. And then the user guesses, well, we'll go like like the right answer, right? When Casper guesses the search term used to find these images.
What was the answer then?
Oh, it's a beaver. So when he guesses beaver, and then the timer stops, right? Because he's got it right. So the timer stops. Boom, 7 seconds. That was quick, computer.
Oh, cool. This is starting to come together. Do we want to give the user a score, maybe? How does the score work?
Oh, yeah. Like, so the faster you get it, the better the score. So maybe, like, if you start with 10, like a countdown, yeah, that would be great. So, yeah, the score is like the remainder for the round. So the time for the round is then the score. Cool.
Oh, yeah.
And in every round, we update the status. Everyone's a winner, right? So status is winner. This is good.
All right. Sounds like you got a pretty solid idea.
Yeah, but Selena, how does this all hang together?
Well, if we just go over, you know, kind of roughly what we've just said, quick recap. So given the app search term, someone decided they wanted to use Reveal.js, and it's a great time for this presentation. So given the search term is set up with spooky terms, yeah, then I'm going to start pointing now. When Casper visits search term, then a welcome message is rendered. And when Casper starts the game, then round one begins. When the game is in progress, then the countdown timer starts counting down. So you can see a pretty clear pattern starting to emerge here, right?
Right. Yeah. Given, when, and then. I can do that 3.
Exactly. So given the state of the world before you begin, when an action is carried out, then observable changes are expected.
Right. So like given I have a beer, when I drink it, and it weighs a little bit less. Okay. I'm getting it.
This, guys, this is almost exactly how we're going to write our first test. But you know what? Why do we care about testing?
Right. Why do we care about testing? Well, you know, it's Halloween, it's scary. And writing code is scary too, because you just don't know when it's going to become a ball of mud and a mess, because there's nothing to catch you. That's why you have to write those tests first. It's a bit like this old-fashioned crane here where you've got a ratchet and paw. And you've got, every time you write a test, it's like one of these teeth that grips in and saves you, saves that load, that chain from letting go of whatever it's holding. So you write that test, it creates this ability for you then to write some code, but you've got a safety net. The safety net catches you, and bit by bit you move forward. You write a bit of test, you turn it, you pass it, and it just guarantees that everything you've written up to that moment actually works. And if there's one thing you take away from today's talk about why testing matters, it is because it's the only way to do incremental iterative development. If you don't want to design the whole thing up front and you want to build it bit by bit and realize that things are different than you actually thought, the only way to do that is to write tests first.
Wow. That's a great explanation. But I'm not sure everyone's quite following. So maybe let's run through an example.
Right. So here we've set up a feature where we have a gameplay lifecycle, like the feature of being able to play the game. And within that, we have a scenario for winning the game. We're going to have a happy path. And within that, we have, as mentioned, this given step. So given the game is set up with spooky terms, ghost, haunted house, etc., that would be kind of our beginning. But the way we at Fresho drink...
They don't know about that rule yet.
Oh. They're learning.
When you hear Fresho, drink.
Whoa.
Fresho.
Sorry, I can't hear you. But in this case, we're writing the flows from the perspective of the user. So the user doesn't necessarily, in this case, work as a given. We then give this a context. So I'm going to rejig some of the code and say there's a feature where the game lifecycle is what we're trying to show the feature of. And one of the contexts is that a game is set up with spooky terms. And then we have a scenario at the end, which is our happy path of winning a game, at which stage we can actually start describing what that is. So when the user starts the game, and presumably they're going to visit the root URL of your app, and they're going to focus on a piece of, a part of the page, the welcome part, and see the text, welcome to the game.
Well, let's just make sure everyone follows along before we move forward. So this, guys, this is the first piece of code in the whole application. We don't have any controllers yet. We don't have any models. We don't have any views. We haven't written any migrations. There's no entries in the database. We haven't even set up the database. The first piece of code is always a test. And when that test runs, what's going to happen? Well,
nothing?
Yeah, it's going to fail, obviously.
Right, so then we want to make it pass. In this case, we thought, oh, we'll throw in a bit of React. Here's a simple React component that spits out a H1 on the page. It says, welcome to the game, which was exactly what we expected the text to be, and it passes. So, once we've ratcheted across one hop, we go to the next and we write another failing test. Still, as part of the user starts the game, we need them to focus on the welcome part and press the start game button.
Hold on, what's focus on? What is focus on? Well, what we've done here is we've hidden away some code that asserts against HTML in order to make these high-level tests a lot easier to read. We've hidden that code away in a module called page fragments. And as you can see here, in this particular fragment, finds the text inside a div with the class of welcome. That's this one here, being used up here. And one benefit of separating out fragments like this is that they're reusable throughout all of your tests. So if you go into the HTML, you change the name of the class, you don't want it to be called welcome anymore. You want it to be something else. I don't know what. You don't have to troll through all of your tests to change every assertion. You can just change it here. And like I mentioned, your tests also become much more readable. Clean, easy to read, easy to understand, easy to follow.
So what happens when we run this and we find the welcome start game and we click it? Well, it fails because there is no button yet. So we still have a failing spec, at which stage we go out and update our React component to say, hey, welcome to the game, and also create a button that says start game. As you can see in the little animation there, it clicks the button, but it goes nowhere because we don't have a test for that yet. We've only built just enough to press the button. Let's see what's next. So at this stage, we need to find out that the game is commencing, and while we kind of said before, we're going to start with round one. So how do we know that? Well, we want to find that the focus on game, the round is equal to 1.
So here we are now, skipping along happily down the happy path. But is it possible that there are alternate happy paths? And what about failure cases? For example, what happens if there is no route? Or what if the next page doesn't load? What's going to happen? Maybe we need to consider those at a lower level test?
Well, those are great questions, Selena, but let's keep that in the back of our minds for the moment and let's keep moving. So right now, we land on this round one page where you can see the path is round/1 and there's nothing there. Nothing there, but so we've got a test that expects that to say round 1. So let's see how we implement that. Again, in this case, we're using React Router, which matches the path element that I'm on and spits that out in a H1. Nothing too complicated. Let's see what the next failure is. Again, we go back, we back ourselves with a failing test, and we're expecting to not only see the text round 1, but also to see 9 images. So we write a page fragment, as mentioned by Selena before, which allows us to find images and expects 9 of them. We're still in a failing state because all it says is round 1, there's no images. At which stage we do quite a bit more. We're not going to cover all of this here, but what's happening here is presumably in our front-end React, we are doing a fetch round data to find the images that for that round we should be displaying. And somewhere in there we kind of iterate through our images and display them. But that's not everything, right? That API call that we've made from React has to go somewhere, has to have an API endpoint, presumably in Rails. That API endpoint is probably connected to a controller. The controller is probably talking down to a model. The model is talking down to a database and then filtering up its result, encoding it in some kind of JSON for the React to kind of get back. Again, we're not going to look at all of those layers just now. This also introduces some network latencies. It doesn't happen immediately. The calls have to be made before they come back. And this can lead to kind of asynchronous rendering, where bits and pieces of the page get shown and then other things move around.
So there's a few things going on here. We're rendering, we're waiting for images, we've got changes in the DOM. So all of these things, they can lead to flaky behavior. So flaky behavior, what is that? That refers to things
it's like this, right? Like eating flakes? Yeah, no, woo!
There's some flaky behavior.
There's some flaky behavior.
That's all the flakes.
That's all the flakes. Minty behavior, that's next month's topic.
No, but in terms of testing flaky behavior, this refers to things that fail every now and again, and it is not good for testing. We want to avoid elements moving around the page. So here's an example we brought to you from Fresho.
Oh, I was feeling a bit dry, thank you.
This is a microsecond transition, slowed right down. You can see in the animation that the test wants to click on the Orders tab. And when the Orders is clicked, the mouse down event occurs. But by the time the logo is loaded, this whole side of the page moves across. And at which point the click event is now on top of the Market tab. So this is now treated like a click and drag event rather than a click event, which behaves slightly differently.
Right, so you wouldn't actually go across to the Orders page because you haven't clicked on it.
Correct. So what was happening here for us was in CI, 9 times out of 10, the logo loads fast enough for our test suite to find what it's looking for, but occasionally it would fail. This was a flaky failure. I just want to point out, fixed by none other than Dave in the audience back there. Thank you, Dave. Woo!
Woo! So let's wrap up iteration 1. What we've done here is set up some context around having some phrases in the database, and we've created two parts. There's a when of actions by the actor, the player on the system, and a measurable result, which is that the game commences, showing that they're on round 1 and they have 9 images.
Right, so on the next iteration, things are going to be a little bit easier because we've got a lot of the context set up already. Adding our new feature, submit a guess, is going to be fairly straightforward.
Right, so to simplify this slide, let's drop the feature, context, and scenario. We just focus on the 2 steps, the when and the then. So let's see how that looks. Right, so we've got the when, the user starts the game, and then the game commences. Now, as Selena mentioned, with this flaky behavior and things taking time to render, it came to us that maybe at this stage we probably need a status. And the status probably initially would be that it's loading, it's making the API call, and then once the API call is finished, it probably goes into an in progress status, but probably there's other statuses, maybe an error status.
And this is where mechanics come in. So the style of test we've been writing here is an integration test. And what we do at Fresho is we organize these types of tests into 2 categories. Flows and mechanics. Flows, like we're writing here, test the user's experience of flow-on effects from both user and system interactions. Take the status, for example. It can be one of, didn't want to say that. For behaviors that are specific to a page or a component, we would use what we call a mechanic test. So if you take the status, for example, it could be loading, it could be round in progress, it could be round complete, or it maybe could be an error. It's not practical to duplicate all of our flow tests and navigate through to a round just to test a different status every time. So specific tests around the round page would allow us to test the status component on its own. If we just take a quick look at an example now, This is a pretty basic mechanic. What you can see here is, I still can't use Reveal.js. And scenarios in a mechanic tend to be a lot smaller. They're ultra specific. And like you could see, we would test something as small as a state change. But the thing is, we would test that that every time the state changes, whether it's loading or in progress or winner, we would test that it happens the way we expect it to and at the time that we expect it to happen. And the other thing we can do, we can also set up additional scenarios around error cases. So things like a network timeout, or the database isn't available anymore, or for some reason drops out. Writing these tests first also makes sure that from the outset, each page or component is individually testable. And you don't have to navigate through a whole sequence of events just to come to one particular edge case that you maybe want to test.
Right, so you wouldn't need like 5 flows to test the status, those 5 statuses you had there, because that would be tested at the mechanic level.
Correct. You would test that once in your flow and then all of the other cases down at the mechanic.
Excellent. So coming back, we're now saying that in our flow we want an in progress and we need a status. Of course, we still have a failing test. We don't have a status anywhere on the screen, so we implement that. And in this case, we kind of come back a little bit to some of the pseudo React code we've got there. Once the fetch round data successfully fetches, we can change the status to in progress, and we can create, in this case, 2 statuses. As you can see, when you click start game, the status is loading, and there's a shimmer effect over where the images go, and once the images are loaded, it goes in progress. Right, so the next part would be to write a test about the user submitting an answer. Right, this is the time for the user to start guessing. Let's guess ghost.
Pending. You might notice something in this test and some of the other tests we wrote previously, this line here, pending. There's no text area to input a guess. So what we can do is by marking a test as pending, all of the assertions that are made after that line, they're still going to be run, but one of them has to fail. There's 2 reasons we might want to do this. Number 1, we haven't implemented the code to assert against. That's the case here. We've actually got nowhere to fill in the guess ghost, so there's no way we can possibly make this assertion. The other reason that you might want to do this, if you're working on master, like we do at Fresho.
Whoa! Anyone else working on master? Cheers.
If you're working on master, have a drink. So if you're working on master, like we do at Fresho, this enables us to push code while our features are still in progress. Pretty cool, huh?
Right, so we have no input. Yeah, very cool. Very cool. I mean, working on master is just one step of working straight on production, right? So we have no input. We need to add an input box. So here we have a text area that has 2-way binding from the text area to a way of handling the guess. And obviously we're getting a term. We're comparing if the term is in there. And, oh yeah, that's not a capybara, it's a beaver. So we're winning there on the animated GIFs. Let's go. So we've finished iteration 2, where we've allowed the person to make a guess. And having a look at the code here, we've basically added another when and then. So when the user submits an answer, then the user wins, because we said everyone is a winner. And coming.
Winner, winner, chicken dinner.
Yeah. So that's a great start, but we need more than one round. At this stage, we're going to focus on the game and click next round. As we see the image, there's currently no next round, so we have to build it. Again, a bit of pseudocode as to how you may do that. There's a link. So again, link is part of React Router that creates a link to the next round, which is the current round plus 1, pretty obvious. And we have a passing test. When we want to land on the next round, we're expecting that it's going to get greeted with round 2. And at this stage, we actually, whoa, where do I go? We write a test to match the text to tell us that it's round 2. And then we get a freebie here because of the way we implemented the rounds. We were from the beginning using the round coming from the path and putting it in that text. So in fact, from the beginning, already our tests are now paying off because we actually created tests well, our code's paying off. We created tests as well, which means this could actually go for any number of rounds.
So if it just passes already, shouldn't you make it fail to see that it fails the way you expected it to?
Ah, good catch, Selena. Absolutely. If you do not see it fail, you may not be testing what you mean to be testing. Even when the tests fail, often developers don't read the messages and trying to make a test pass when the message is right there in front of them. So always remember, read the output of the test. If it doesn't fail, make sure you know what the output would be if it failed, because you always need to know that you are testing the right thing. So make sure you see it first fail before you make it pass.
Right, so the key here is to make sure that it passes for the reason that you think it does, not just that the test goes green.
Yeah.
Cool. That was simple. Basically, a rinse and repeat. There you go. 3 very basic iterations of TDDing a flow. By stepping out the sequence of events that take place in this style of test, it's very easy to make additions and adjustments to the way that the app works. We've only shown you a snippet here of one flow that happens to go down a happy path. But like I mentioned before, there might be a number of happy paths and there might even be some not so happy paths. In fact, there are going to be a number of flows that emerge before this game is complete.
Show me the code, Selena. Yeah? Yeah, I want to see. Who wants to see the code? I want to see it run.
Yeah, no?
Yeah. Well, I don't care what they want to see. I want to see the code.
No. We'll have a look at the code. So we've given you a high-level overview, right? But let's just look at the real tests. I brought him here just to hold the mic, so what I'm going to...
Respect.
What I'm going to do now is run RSpec, so that's what we're using. And here we've got Selena running Capybara to drive the browser. So shortly the browser, there we go, it's going to pop up. So this is a recreation of the tests that we're running. And you can see here in the terminal, this is what the tests look like when it actually runs. We've put in a few binding price so we can stop along the way. So right here we've got a setup, and what's going to happen is when we click start game, let's see what happens. You'll get the expectations of a new game, which will show up. In the top right there, you can see hopefully you can see a timer in progress. The countdown's on. Status in the top left in progress, and the images have all loaded. So cool. Next, what's going to happen is when the user submits the correct answer, you're going to see that the timer stops. The status is now winner. We've made those assertions in the tests as well that you can see on the right-hand side in the terminal. And if we go next, we're going to head on to the next round. Round 2, you can see it right there in the front. Timer started counting down again from 60 seconds, I think we gave you. This time, the user is going to submit the wrong answer. So when the user submits the wrong answer, you can see here the timer doesn't stop, the status doesn't change. We're not ready to move on to the next level, next round. Now the user submits a new line and a correct answer, and boom, timer stops, got a new score, winner. In this test setup, we've made it 2 rounds. So next up, what's going to happen? You click the next button. You're not going to go to round 3. You're going to go to the winning screen. Woo! 75. Not a bad score. Not bad, huh?
Yeah, well done. That's your best today.
We only rehearsed that a couple of times. But just because we built the game, I reckon we should play the game. Who wants to play the game? Do you guys want to play with us? Yeah? Well, you should. Come on, let's have a bit more than that. We're going to play the live game here now on stage.
All right, so we're going to take some audience participation only. We need you guys to yell out. I'm going to press the start game. We've got 60 seconds. Ready? Hang on, I'll move some post-it notes.
Tell us what the answer is. Michael's going to type in. We're going to test his touch typing ability.
Go!
How quick is he?
Pressure. Which one's mine? That's yours.
Time is counting down. We're counting down.
They said Fresho.
Quick,
They said Fresho. Fresho? No. Ghost. Oh, yeah, we got that. We got that. I pressed enter. It's too excited.
Spooky.
Oh,
Spooky.
No, I can't.
Already?
Spooky.
No, spooky. How do you spell spooky? It's on the screen.
Winner!
All right, what have we got? 97's the score so far. Next round.
Whoa, 57.
Wow.
Let's go.
What's this one? Haunted House. How'd they get that the first go?
I actually talked to a few people that played the game before.
Oh,
Yeah.
right.
I love it. It's great. It's broken the internet. Next.
Halloween pumpkin. Jack-o'-lantern.
What? Jack.
It really helps if you can type.
Lantern.
Didn't you tell us about touch typing once?
Yeah, I did. This is a great skill. You should learn it, like VI on the command line. Pumpkin. Oh, pumpkin!
was the answer.
No.
250. I beat your score. Woo!
What a good score. Round of applause for the audience. Nice job, guys.
Thank
well
you.
done. I think that's enough fun, though, for tonight, all right? Take it easy. Let's have a recap on the tests. So, most apps have a database of some sort, right? And they've got, in Rails applications, we all know Rails, they've got models which talk to the database. And these traditionally get tested as a DB integration, database integration. At Fresho, we also like to unit... Sorry. At Fresho...
You say it again.
I'm one behind. We also like to unit test the models. Oops, I'm going backwards.
Do you have to say that F word again? No.
So, models often can interact with service objects. These service objects might talk to external services. You can see here another boundary for testing, the green line there. We would have external integration tests which mock out the external service and ensure that everything is, what did I want to say? I can't remember.
Isolated, excellent.
Yes.
We,
you.
we primed the biggest heckler and we've got him to help us instead. Great.
So, models also talk to controllers, and in this case, they present an API layer. So controllers are traditionally tested as integration tests, which include the model and the database, like particularly in Rails applications.
Yeah, and they test the whole active record.
Oh, and the view. Thank you. But we don't do that at Fresho. Sorry. Because we don't need to test active record. That's not part of our application. Instead, what we do is isolated controller tests, which focus in only on the controller behavior and mock out all of the collaborators for that controller. We also treat the API as a unit, and we do a full integration test at that level. You following along, Michael?
I'm following along, keeping up.
And in this application, like so many people do now, our front end is a single page application or an SPA, a SPA. Is that what they call it? SPA?
Yeah.
I don't know. I haven't been around long enough. A SPA, you might hear it referred to. It's made up of a number of components, at any rate. And each of those components will be unit tested as well in isolation. So now we move on to testing the user experience of the app. The example we showed you today is basically a flow through 3 pages, but we want to test that each of those pages works as expected in a mechanic test, integrating with the whole back end. And lastly, that brings us to flows. We test the flow-on effects of user interactions between front-end components and pages. We cover the whole application, with the exception of external integrations, because they're not really part of our application.
So, In review, remember...
I just want to say Fresho one more time.
Did you just?
I feel dry after that.
So remember, like at Fresho, write your test first. Start with a flow of your system. Remember to test each page with a mechanic or each part of a page with a mechanic. Hide away any of the particulars in a page fragment. Don't let flakes put you off. Buttons jumping around and making flaky tests are probably annoying to users as well. Mark tests as pending, so always be committing and pushing to master. And like we do at Fresho, iterate.
Sorry, I think I'm one behind. But if you think you can beat our high score, and I think some of you have already tried, then you can check out the app. It's hosted here on Heroku. And you'll find the link on Ruby Meetup or on our latest tweets. You can also follow us on Twitter, right here.
Wow.
That one's me and that
That's
one's
me.
Michael.
Yeah.
Just in case you were unsure.
Thank you very much.
I have a question.
Yes, question, gentleman in the front with a big square cube.
Yeah, where do you guys work again? I can't remember.
We're working at a business-to-business marketplace where we're very passionate about pairing, passionate about testing, and passionate about fresh food. Fresh food.
Oh, that's how you
Yes, you're allowed to throw it.
Not like the chocolates.
This won't hurt you, it's soft.
I was wondering, I didn't catch how you caught on the flaky thing, how the button moved as I was painting. Like, how did you guys fix that part?
Dave, do you want to answer
Come
that?
on up, Dave. Round of applause for the man who actually found it.
Techniques that we use to capture these flakes, and I probably won't remember them all, but some of them are just slowing it down using your browser tools. So you've got slowing down the network, slowing down the CPU. We actually recorded after slowing it down, we recorded it on a phone, like in slow-mo, before we realized we could do it for the browser. And then, just sort of just keeping a close eye and looking for these like things that are moving around. There's heaps of other techniques as well.
And it's interesting, just to add to that, we grab screen captures at the end when a test fails on CI, and we see the images and we see, why is this broken when you can clearly see the button has been pressed? And often it was because something just jerked or moved. We had flash messages that appeared and disappeared randomly, and the whole page would move up and down. And one of our actually employees, when they were checking out going through the airport, they had a similar error in the system because it said, do you have any dangerous goods on you, yes or no? And as they were pressing the button, it actually moved and made them say yes, at which stage security guards came from everywhere. So you may kind of dismiss some of this going, oh, that's just in CI, it's just the automated test. Users do not want that behavior.
I did have a gun.
It was Mark here. He's got a gun, ladies and gentlemen. Yes, that's why the people are leaving in the back. Any other questions? Got one there. Throw the mic. There.
Oh, I'm going to turn it off. There we go. So I'm new, and I know that there was RSpec involved there, but what other things were you using? I haven't seen the when syntax and such, so some of that was a bit foreign to me. What parts of RSpec are you modifying there?
So yes, we're using a number of gems. The feature and scenario are standard RSpec.
Oh, cool.
The when, given, when, then are part of a gem which is called RSpec steps. So that will give you that. And the beauty, I think. We think. Well, let's have a look at the code, hey, shall we?
Yeah, if you look in the gem file.
So if we look at the best editor ever,
It is pretty good. Does anyone know how to scale up the code, like the font, like really quickly with the keyboard?
Command plus.
no.
Not on Ruby Mine.
No, not on Ruby Mine.
So much for best editor.
Whoa!
No, that wasn't it.
What'd you do?
Presentation mode. He's got to find the option.
Ruby Mine.
That's fine. Open that.
Is this even the right project? No, this is the Reveal.js. Does anyone love Reveal.js here? No one. No one knows what we're talking about.
Neither do I. We thought we'd give it a go.
No, I don't know. It's probably aspect steps or something like that. We're using Capybara to drive out a lot. The other one is wait for. So what wait for does, so that is...
Didn't we use wait?
Wait for gem or something?
We used wait, right? Wait for is a hack.
Wait for is no, wait for is a gem. It's not a hack. Oh my god, like beginners.
The gem is called aspect weight, but
Let's hear from an expert.
but we've monkey badged it to work properly.
Right, so in here, let's quit out of that. Control C, and use the actual best. Oh yeah, it's. Oh wow, that was cool.
One of the benefits of VI on the command line, guys.
Yeah, there we go. Command plus, there you go. So we are using, what are we using? Oh, down below. Aspect weight.
Example steps.
Aspect example steps, Capybara and Selenium WebDriver. So they're the secret sauce that allows us to do that. Now the key here for anyone who's ever run Aspect to do these kind of tests, you end up just writing a whole heap of assertions of when I go to this page and I click this button and I fill this field in and I click this next button, and when it fails, all you get is to say, oh, it's on line 56, and you're going, I don't know what that is. Whereas now with RSpec example steps, you get the given when then, so you bring those blocks together, it spits out that, as we saw in the demonstration before, it actually spits out nice text, and when that runs on CI, you get to have these readable steps, and it also tells you, oh, I failed at step 3, which was when I click the start game button.
Once you get to some fancy tests, you get to also have the and step or the but step.
I'm not going to say anything. Does anybody else want? I want to throw this microphone. I don't know who wants it.
Throw it to the front. Throw it
Someone
to the
ask a
front.
question.
Yes.
I got a question.
So at Freshie, do you always do these 7 layers of testing?
Sorry, I really do appreciate the fresh.
Sorry, 7 layers of testing? More like 17 layers of testing.
But for every piece of code you do, like, is that all through your code base at Freshie? That's like the code base is 100% tested in. Do you have
Yes.
like legacy stuff that's
So there is legacy. Fresho.
We're not 100% tested. We do have some legacy code. Every new piece of code, however, is tested from the outside in through a number of layers, depending on the piece of code that it is. That's all I have to say.
Yeah, so we do use those layers, and what we notice is some of those layers don't always get used for every new feature because there's already tests there, or there's tests that are unit tested around the controller or the API, and we go, oh, we actually don't have to add a test there because the controller is just letting data flow through, so it's still letting it flow through. When we have a mechanic around, let's say, things like statuses or errors, once we catch one error, that's enough to know that when the back end throws an error, it will get displayed on the page. We would then do unit tests to say, oh, there's now a new error, which may lead to a different message.
Okay, so my actual question without the trolling is when you do refactoring, do you find that the number of tests sort of like locks you in? And so when you try to refactor classes that your tests all fail because they're sort of tied so tightly to your implementation?
Well,
Not for the new features.
No, not necessarily, right? So again, we are doing things like controller unit testing so that everything underneath can be moved around because we're not actually dependent on all of that. The aim of the API tests, again, are everything can change as long as your API doesn't change, and it's important to make sure your API doesn't change. Your front end can change as long as it's still holding that contract with the API, and it won't break. So it's not this pyramid of like a traditional kind of maybe Rails approach of saying I do a model test and a controller test and a view test and build out to a front end test. We do break some of those things up. And again, with a lot of the top level tests, the flow tests that we showed today, they are underpinned by things like page fragments, which you also want to change. And by changing those, the flow test should theoretically just go along with saying this is the new way of clicking the button. Maybe it's sliding a slide.
Additionally, with any change, we always start from the top layer. So we'll change a flow first. We'll go through and find the mechanics. We'll change the mechanics. We'll go and find the API acceptance tests. We'll go and change those as well. We may be pending at that point. It might be the end of the day and we want to push to master. So we'll push away. We'll come through. We'll change the controller at the unit level. We'll change the model tests if they need to be changed. We'll change the DB integration tests if they need to be changed. We'll move on to the front end. We'll change the component tests if they need to be changed. And we'll come right the way through. So nothing is really untested.
I think that was good. She went through all 18 layers in like 20 seconds. Question at the back.
Here's a hard question.
No, pass it to me.
Our way.
It's not a hard question.
Right, got to hold all the things. How about reusability with those aspect steps, like versus Cucumber? Like step reusability.
Step reusability in Cucumber is bad.
It's not. It's awesome.
Are you talking about like shared steps?
Okay.
Like
No, I
aspect
find
shared
it to be
steps?
really, really powerful. So I just wanted to hear an opinion, container from you guys.
Do you mean like aspect shared steps?
Sorry?
Do you mean like aspect shared steps?
No, way before your time.
No, that's not what I mean.
No, you mean about shared steps. So if I remember...
Opposing tests from other steps.
So if I remember correctly, you would have like some of those given when thens as like wrapped up in a Cucumber step. What we've...
Is this like a shared context?
Not necessarily. It's not a shared context. It's just a number of things. What we often do is wrap certain things in macros. So then we say, right, this is a macro for signing in. This is a macro for checking out.
You mean it's Ruby?
Sorry?
You mean it's Ruby?
Yeah.
Ruby doesn't have macros.
Well, we
call them macros.
We're calling them macros, like a macro. It's a method, right?
C, it's not a macro.
Can we call them a racro? Like a Ruby macro?
Look, ultimately, we do like to treat a lot of things as plain old Ruby. So we will have a method out there that will go and do a number of things, right? So that's where the reusability happens, where if it's something common like logging in, maybe adding something to cart, maybe creating a particular report. Plain old Ruby. And the reason for that, in fact, we tend to keep away from a lot of idiomatic RSpec just because it's very hard to read. We didn't have...
Idiomatic.
Yeah, I'm coming around to it. That's fine. Just because there are clever tricks you can do in RSpec doesn't mean that 6 months later you can actually read that code. And I think we touched on it a little bit, but a lot of our tests are very verbose about creating a particular scenario of somebody. So it was Casper. It wasn't just like when user logs in. It's like when Casper comes and navigates to the search term app and then does this. Because we want somebody, we don't care about the efficiencies of writing the code there and then. We want them to be able to come back and say, oh, it's all Ruby. There's no magic. There's no lets inherited from lets up the top. There's no hidden context that you can't easily find. Everything, we tend to go back to plain old Ruby for that.
And at the end of the day, we're more inclined to lean towards, despite what Michael might say, more duplication in favour of readability of tests.
Yeah.
Woo! Thank you.
Can you show an example of your aspect style?
Respect, yeah. I'll show you later on. Actually, I need to talk to you about Reveal.js. You did a presentation in that, and my partner here is like, whew, not happy.
This was a terrible,
Oh, you did
terrible
Slider?
idea.
Okay, so very similar.
All right, thank you very much.
Thank you.